Hello students, in this session we are going to study the cantilever beam with UDL. There is a cantilever beam, UDL is there on the entire length, and we want to find out the deflection and slope of this beam, maximum deflection, maximum slope. Basically our aim is to find out the maximum deflection and maximum slope for this beam using moment area method. We have already done using the double integration method. Now we want to use the moment area method for this beam. We know that we have two theorems, Moore's first theorem and second theorem. With first theorem we will get the maximum slope, and with using the Moore's second theorem we will get the maximum deflection, right? So we will get this type of elastic curve. This B point will be shifted to this point B dash, right? The slope will be maximum at this point. The slope will be maximum here. This is the maximum slope, theta max or theta B, and the deflection will be maximum at this point, at B only. This is Y max, right? So we have to choose 2 points such that we can apply the Moore's theorem. So we have to choose the 2 points such that one of the slope is 0 and another slope is maximum, so that the maximum slope can be obtained, right? So we have chosen, we know that theta B is theta max. So we can choose B point, one of the point, because we want to find out theta max, and another point, choose the point where the slope is 0. So A point is that point where the slope is 0, and we know that theta A is 0. So now the difference of these two slope, difference of these two slope can be obtained from the area of the bending moment diagram. So theta B minus theta A will be equal to area of the bending moment diagram between A and B divided by EI according to Moore's theorem. This is the Moore's theorem, right? And we know that theta A is 0, so theta max or theta B can be obtained by the area of bending moment diagram between A and B divided by EI. So this is the theta max, right? This is how we can find out the theta max. This area is the area of the bending moment diagram between A and B, right? A is the area of bending moment diagram between A and B. Now first of all we have to draw the bending moment diagram so that we can find out the area. So draw the bending moment diagram. Draw the bending moment diagram. Take the section here. Yeah, we have already done in our shear force bending moment diagram. You can go there, or you can make it separate section here, and at a distance x, from the free end, take a section here, and we know that the area of this part, the load of this part will be W kilonewton, so Wx, so this will be Wx, right? Wx, which will be lying at a distance of x by 2 from the x, right? So it is x by 2 from the x, right? So this is x by 2 distance from the x, right? So bending moment will be, what will be the bending moment? Bending moment mx, that will be the moment of this Wx about x, moment of this Wx about the x point, right? So moment of Wx is, because it is hogging bending moment, this is Wx negative, so minus Wx multiplied by x by 2. So this is minus Wx multiplied by x by 2. So this will be minus Wx square by 2, right? And we can choose the 2 points A and B. If we draw on the, and it is valid between A and B, it is valid for A and B entire length, from B to A, you say from, because starting from B ending at A, because we are taking B x from B point, right? So it is valid from B to A. So at B point where x is 0, bending moment will be 0, and at A point where x equal to L, because the length of this beam is L, so at A point x is equal to L, so the bending moment will be minus WL square by 2. Now it is a parabolic curve, it is a parabolic curve in negative direction. So negative sign is here, right? So you can draw at A point, this is at B point, this is 0, bending moment is 0. At this point it is this value something which is W L square by 2. This is W L square by 2 value on the given scale, any scale, and this is a parabolic curve, convex inside. So this is the like this, right? This is a curve. This type of curve will be obtained, and this is negative, right? So this is negative, right? So this is a parabolic curve. Parabolic curve of type of parabola is parabolic. You can see here, this is W x square by 2. The curve is like this, is a function of x square by 2, parabolic curve. What is the area of a parabola? So for triangle, we know that for a parabola the area is 1/3 of base multiplied by height. For triangle, this is half into base into height. For parabola, this type of parabola we already know mathematically, right? The area of this parabola will be 1/3 of base, which is L, multiplied by height, which is WL square by 2. So this area between A and B, starting from A to B, so the area will be 1/3 of this base multiplied by this height, WL square by 2. So this will be equal to WL cube by 6. So this is the area of this bending moment diagram, right? WL cube by 6, right? Put the value of this here, we will get the theta max. So theta max in this case will be equal to area between A and B, which is WL cube by 6 divided by EI. So this is WL cube by 6 EI. So this is the area, this is the slope, this is the maximum slope which is obtained at point B, right? At this point, which is obtained at point B, this is theta B, right? Maximum slope. Now we want to find out the maximum deflection. How to find out the maximum deflection? For maximum deflection, we have to choose, because the what is maximum deflection? Maximum deflection is what is Moore's second theorem, that take the tangent on the elastic curve on a reference vertical line. So let us choose a vertical line. Suppose this is our BB dash is our vertical line. BB dash is our vertical line, right? So this is vertical line, not curved. This is vertical line, right? BB dash, this line. Right? This is the vertical line. BB dash is our vertical line. On this vertical line, take the slope. So one of the slope will be of B dash and another slope will be of A, so that we can find out this distance, because our aim is to find out this distance, Y max, right? So the slope of this A, tangent of this A will be passing through this point, horizontal line. So this is basically tangent of A, right? Tan A, right? Which is a horizontal line, right? Or from this horizontal line, we have to go to the maximum slope. So maximum slope will be at this point, and it the B point, and we will get the slope of B, right? At this point, which is cutting at point B, right? So Moore's theorem says that the moment of area about this reference line will give the deflection between these 2 points, right? So this is our reference line, right? And to find out the deflection, we have to take the BB dash as the reference line, right? So Y max can be obtained by taking the AX bar by EI, that the area between A and B, this is the area between A and B, and moment of that area means X bar, right? So moment of that area is X bar, right? So now what is AX bar? So the center of gravity, centroid of this area about CG, its CG will be lying at certain this point. The parabola, this is a parabola, and CG of parabola lies, for triangle it is 2/3, for parabola it is 3/4, right? 3/4 of the from the vertex. So this distance from the reference line, this line, will be 3/4 of the total length. 3/4 of the total length. You should remember this thing, right? This is the 3/4 from the centroid. This is our centroid, right? So from the for parabola, this type of parabola, the CG is at a distance of 3/4 of total length from the vertex, right? So the total area, this area WL square by 6 will be lying at this point. At this point, this total area will be lying A, and that will be equal to WL square by 6. So taking moment of this area will be, and this is x bar. This is x bar, suppose. So moment of this area will be A x bar. A multiplied by this distance will give the moment of this area. So A x bar will be equal to area, which is WL square by 6, this thing, multiplied by the x bar, which is 3/4L. So this will be equal to 3/24 WL cube. 3/24 means 1/8. It will become 1/8. 1/8 WL cube, right? This is the AX bar, right? So Y max can be obtained as AX bar. AX bar is WL cube by 8 EI. So it will be WL cube by 8 EI. So this is the Y max, maximum deflection. WL cube. This is WL cube. This is not WL square, this is WL cube. So this is WL to the power 4. WL to the power 4. WL to the power 4, 8 EI. So this is the maximum deflection. So how we obtain this? We have a cantilever beam with UDL, right? You have to select 2 points. In cantilever beam, we generally select the end points A and B. We take the slope at these 2 points. So difference of these slopes will give is given by the area of the bending moment diagram divided by EI between A and B. So this is the we have got, and area is 1/3 of base into height. So this is 1/3 of base into height, WL cube by 6. So this is the theta max, because theta max is theta b minus theta a, and theta is 0. So we get the difference of slope as theta max only, right? And Y max will be obtained by taking the moment of area. Area is already obtained, and moment of area we have to take the centroid. Centroid is lying at 3/4L from the vertex. So taking the x bar as 3/4L, we obtained 1/8 WL to the power 4. So Y max will be equal to WL to the power 4 by 8 EI.